Today's lesson will be on the formation of the universe. Today you will learn about the Big Bang Theory and the two pieces of evidence that support it. You will learn about how old the universe is. You will learn what materials make up the universe from the largest to the smallest. And then we'll very quickly touch on what galaxy we live in and specifically what kind of galaxy it is. This here is a picture of the view from the Hubble Space Telescope. It's looking out deep into the universe, and then these little dots here that you're seeing, these are actual galaxies that are very far away from Earth and our own galaxy itself, and then some of these little dots represent stars. These are the pillars of creation, and this is Orion's Nebula. So how do we believe that the universe was formed? It is believed by scientists that the universe is the result of a gigantic explosion from which all matter and energy came from a single extremely small point, okay? And this small point contained all the matter that's in the universe that we see today. Now, as these small particles started to move away from the central point after the explosion, we started to see that mostly we had hydrogen and helium existing. And then about 1 billion years after this explosion, we finally saw stars forming. And those stars eventually were grouped into galaxies. All of this is explaining that the universe we see expanded from that extremely central point. And from evidence that we see today, we know that the universe is still expanding. So let me explain that a little bit more. If we look here, this is a picture of what I was just talking about. This is where we believe time began. All Earth's material was forming in this central point, okay? And then after the Big Bang, which was that explosion, we had all this material moving away from that central point. As it moved away, it started to condense and form together. We saw a lot of hydrogen and helium forming. Then as we move away, we started to see stars forming. Those stars form into galaxies. And then eventually we're seeing the planets, the solar systems, all the material that we see today. So again, Big Bang states that everything was in a central location, and then it started to move out away from that as time went on. So the universe itself is expanding away from that location. Okay, so the Big Bang is the hypothesis about the origin of the universe. Remember, this isn't set in stone. No one was around during the time that this was forming. It's just our best guess as to what actually happened that long ago. The evidence that we're going to talk about today is the expansion, which I've mentioned a few times already, and then this cosmic background radiation. So let's talk about expansion first. Expansion has to deal with the redshift of surrounding galaxies, which we talked about yesterday in our lesson. Remember, redshift deals with the Doppler effect. The Doppler effect talks about the shifting of wavelengths. So if we look at this picture here, if an object is moving towards an observer, the wavelength is going to be a lot shorter, showing us a blue shift because blue light, it has the shorter wavelength. If an object moves away from the observer, it's going to show the red shift, where we can see the wavelengths are further apart, and red light is longer than blue light. Okay, so when we look out into the universe and we get information back through electromagnetic waves, we can see that a lot of these galaxies have this red shift, which leads us to believe, and that's what Hubble eventually came up with, that the universe must be expanding because we see so much redshift in the universe. The second piece of evidence is cosmic background radiation. This is thermal radiation that we find in space in the form of microwaves. This energy is assumed to be left over after the Big Bang. Okay, so we find so much of this out in space and we wonder, where could this have possibly come from? We can hypothesize that it is the energy left over from the Big Bang. Okay, so our two pieces of evidence here are that we have observed the redshift with many galaxies out in the universe, which shows that they're all moving away. And then we do see we have leftover energy here from the Big Bang, which is called cosmic background radiation. So how old do we think the universe is? So how long ago was this Big Bang? We think it's approximately 13.7 billion years old, but you'll hear anywhere from 10 to 14 billion years often stated. Okay, so you can't really even comprehend how long ago that is, considering the average human lives about 100 years. But billions of years, that's a really long time. To kind of put that into perspective for you, we believe Earth is about 4.6 billion years old. So that means the universe was around almost 9 to 10 billion years before the Earth even started to form. Okay, so you can just, if you think the Earth is old, the universe is way older. So, what makes up space? What makes up our universe? Let's talk about this from a large to small perspective. Obviously, the universe is the largest thing, it's everything everywhere. But what comes next? That would be galaxies. Okay, galaxies are made of billions and billions of stars. After that, we have solar systems. And in our solar system, we have stars. So, think about our solar system. Our star is the sun. Next would come stars, after that planets, and the smallest piece of material that's out there we put into the category solar system debris, which would be anything from comets, asteroids, or meteors. So let's first talk about what's after the universe, which was those galaxies. This is the fundamental unit of the universe. They are the single largest structure that make up the universe. The universe itself, if you remember the picture from the Hubble Space Telescope at the beginning of this movie, is made of hundreds of billions of galaxies. And within each of those galaxies, there's thought to be over 100 billion stars. It's really hard to comprehend that number because, like I said, we only live for 100 years, so even talking about billion is a little difficult. But hundreds of billions of stars and hundreds of billions of galaxies, that's a lot of material in our universe. All of these galaxies are held together by gravity, along with gas and dust. And specifically, our galaxy, hopefully you know, is called the Milky Way. Our galaxy, the Milky Way, is a spiral galaxy. There are different types of galaxies, but ours is spiral due to its spiral shape. So if you look here, this is just a graphic of the Milky Way. And where are we within this galaxy? Well, we are thought to be right here. Here's the arrow for our sun, which is near this bulge and this arm here, which is called Orion's arm. Okay, so we're kind of right here, and then there's over 100 billion stars within that. Our next neighboring galaxy is called Andromeda. That is also a spiral galaxy, and that's pretty far away, but as far as we can talk about relativity here, we're that's our closest one. Okay, so as a result here, our formation of our universe was about 14 billion years ago. We believe the Big Bang Theory with the evidence of expansion and cosmic background radiation. And then remember what makes up space. Make sure you can list them from large to small, and we live in the spiral galaxy known as the Milky Way.